Okie dokie, here's the next part. Okay, concurrency, which we just said, a point of concurrency is where the lines meet. Okay. In lesson 6.2, we learned that we can create a perpendicular bisector to any line or line segment. Similarly, we can create the perpendicular bisectors to each side of a polygon, such as a triangle. When we do this, these bisectors meet at a single point, which is called a point of concurrency. Okay, all of these triangle centers are going to have a point of concurrency where they all meet. Okay. All right. Now, circumcenters. The one I just showed you was from an obtuse triangle, and notice the circumcenter was outside. In a right triangle, it's going to be on the hypotenuse, and in an acute triangle, it's going to be somewhere inside the triangle. This is the only one that's like that. Okay, again, perpendicular bisectors do not have to come from a vertex. As shown, the point of concurrency does not have to exist inside the polygon in here triangle. Wherever it's located, it is perfectly equidistant from each of the vertices. Okay, so remember that one. Perpendicular bisectors are equally distant from each vertex. So this point right here is equally distant from here, and from here, and from here. Okay, that's something to remember because you'll use that in problem solving. Okay, I'll speak well the English. Concurrency and perpendicular bisector theorem. I give up. A triangle's perpendicular bisectors intersect at a point of concurrency that is equidistant from the vertices. So can you see each of these deep orange lines? They're equally distant from this point. And if we measured it, we would find that. Okay, so circumcenter, equally distant from the vertices. That's something to try and remember if you can. Okay, here's a model problem. Examine the diagram to the right. The triangle's three perpendicular bisectors intersect at a point of concurrency 7, 4, which is exactly 13 units from each vertex. Okay? If point R is in the first quadrant and has an x-coordinate of 12, what is the y-coordinate? All right, now they did a whole bunch of stuff here. Notice what they did here is they made a right triangle, okay, and this was 13, okay, so they wanted the coordinate of this other point here, and they used the Pythagorean theorem. Then they came up with an equation, then they factored, and then they got the point. It was at 12, 16. We're not going through all of that. I mean, we certainly can look at it. So notice what they did here. They made a right triangle, and then a squared plus b squared equals c squared. So whatever it was is going to equal 169 because that's what 13 squared is. And they kind of use like vertex form. We're not worried about it. This is what it is. We are not worrying about it. Okay, circumcenters, again, it's the center of the circle that can be circumscribed around the circumcenter, this point where the bisectors meet. Okay, we got that. All right, we're moving. Okay, so now look what I did with this one. Calculate and graph the circumcenter of the given triangle. This one was a horizontal and a vertical line, so I just counted and figured out the midpoint. And the midpoint of the third side is going to go through there anyway. Okay? So this is the circumcenter. And again, I'm going to show you the circle. It's the center of the circle that I can draw around the triangle, and all three vertices are going to touch the circle. Of course, not necessarily how I draw, but you know. Okay, you see it? There we go. So that was an easy one. We're not going to spend a lot of time on this. And they did the same. Well, they didn't do the same thing. They did like the midpoint formula. And if it wasn't on the vertices, we would have to do that. But if it wasn't on the coordinate plane, we would have to do that, but we didn't have to. Okay, so if you notice, our point was at 1, 2. Okay, and notice y equals 2. They're doing the midpoints with just not worrying about this. We found an easier way to do it. There's no reason to reinvent the wheel. Okay, and they ended up doing the same thing we did. Okay, now the mayor of Sportston wants the town hall to be the same difference from the football, baseball, and soccer stadiums. Notice this is an acute triangle, so it's going to be somewhere smack in the middle. How might he locate its exact position? Again, what we just did. The perpendicular bisectors, where they meet, is equally distant from each vertex. So he can use the perpendicular bisector. So he can use the circumcenter, and we could draw it with the compass, but we're not going to. And we could put this on a graph, and we could figure it out, but we're not going to. Okay? The perpendicular bisectors are going to be equally distant from each vertex. Notice each of these places, the soccer stadium, the baseball field, and the football field, are at a vertex. Okay, because they're connecting them all to each other. All right, and here comes the answer. Okay, so they drew it. It's lovely. We already know. And this is the work they had to do it. They had to find the midpoint of each one. Then they had to find the slopes, and we're just, yeah, there's more. But wait, there's more. Okay. Now this one I included because it's not so bad. Okay, let's take a look. Okay, exercises 3 and 4. Use the diagram to answer the following questions. D is the same distance from the 3 vertices of the triangle. Okay, what is the coordinate of A? Okay, D is the same distance from each vertex, so A is the midpoint. Okay, so if you could just use the midpoint formula and figure out the midpoint between here, and it's going to be 1 minus 3, so it's going to be negative 2 over 2, which is negative 1, and 2 over 2, which is 1, so it's going to be negative 1, 1. That's the coordinates of A. Okay, negative 1, 1. It's the midpoint. Where am I? Negative 1, comma, 1. And I think you could probably see that there. And then, there we go. The midpoint from B, okay, from 1 to 3, okay, is 4 steps, so it's going to be 2. Okay, the x coordinate's going to be 2. And from 4 to negative 4 is 8 steps. Okay, so it's going to be 2, 0. Okay, because 4 plus negative 4 is 0. 0 divided by 2 is still 0. So it's going to be at 2, 0. Okay. Okay, so what I did was I figured out the midpoint. The difference, I added these together. 3 plus 1 is 4. 4 divided by 2 is 2. That's the midpoint formula. It's x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay? All right, so I'm going to stop here and pick it up in another video. I don't want to overwhelm us like I did before.